Hi everyone, it's Mrs. Marcellus in Einswine. We're ready to continue on our fun-filled fraction adventure. Now that we've mastered multiplication of fractions, we're going to move on to division. Today's learning objective: students will find the quotient of a whole number divided by a fraction and a fraction divided by a fraction by applying area models and standard algorithms. Today's vocabulary: reciprocals. Reciprocals are two numbers with a product of 1. That means if we multiply them together, they will equal 1. If we look at our two examples, we could see that we could cross-cancel all of the numbers in these examples to become 1s, and they would equal 1. So basically, a reciprocal is a fraction that has been flipped upside down. To divide a whole number or a fraction by a fraction, we are going to multiply by its reciprocal. We're going to leave the first fraction, the dividend, alone. That is our starting point, and it's the thing that we're dividing, so we don't want to change that value. Next, we're going to change the division sign to a multiplication sign. Then we're going to flip the divisor, the second fraction, and solve the multiplication problem. That doesn't sound too bad now, does it, Einswine? We're basically just going to turn every division problem into a multiplication problem, and we already know how to do that. I think we should give it a try. First, let's practice finding some reciprocals. To find a reciprocal, we just flip the fraction upside down. The reciprocal of 7/9 is 9 over 7. If I multiplied these two together, they would equal 1 because everything would cross-cancel. The reciprocal of 1/8 is 8 over 1. And the reciprocal of 12 is 1/12. As you know, we can write a whole number over 1 and then we flip that over. Let's divide 2 by 1/3. First we'll use a model and then we'll look at the algorithm. I will start with 2 whole units and then I'll divide them by 1/3. When I do this, I'm basically breaking these 2 whole units up into thirds, and if I count, I can see that I have 6 pieces. Therefore, 2 divided by 1/3 equals 6. I can also use my knowledge that every fraction is a division problem and flip that around and say that every division problem is a fraction. I can write my division problem as a complex fraction of 2 over 1/3. If I want to simplify this fraction, I need to get rid of the 1/3 that's in the denominator. In order to do that, I can multiply by the reciprocal of 3 over 1. This will cancel everything out, and my denominator becomes 1. If I do that to the bottom, though, I have to do it to the top as well. So I must also multiply the top by 3 over 1. 2 over 1 times 3 over 1 equals 6 over 1, or 6. I can see that if I take my first number and multiply it by the reciprocal of the second number, I end up with my answer of 6 over 1, or 6. Every division problem will be turned into a multiplication problem to solve it. To solve 6 divided by 3/8, I'm just going to use the algorithm. We always leave the first fraction or number alone. That's because this is our starting point. It is the amount that we are going to divide up, so we never change that. I'll go ahead and write 6 over 1. I next turn the division sign into a multiplication sign because we're going to rewrite all division problems as multiplication, and then I find the reciprocal of the second fraction. That would be 8 over 3. Then I have a multiplication problem that I know how to solve. I can now cross-cancel, so 3 divided by 3 is 1, and 6 divided by 3 is 2. And I end up with an answer of 16 over 1, or 16. 6 divided by 3/8 equals 16. Let's try to divide a fraction by a fraction. First, I'll start with a model, and then I'll show you the algorithm. Let's do 5/6 divided by 2/3. We start with a model with 5/6 shaded. we can see that that is 5 blocks. Then we mark off 2/3 of that whole. 2/3 would be 4 of the 6th. So we can see that it takes up 4 blocks to make one group of 2/3. We have one group of 4 blocks and then one left over. So this would be the same as having one whole 2/3 and 1/4 of a 2/3 in that 5/6. So 5/6 divided by 2/3 equals 1 and 1/4. Writing our problem as a complex fraction is how we get our algorithm, but we probably don't want to go through all those steps every time. So let's solve this one using just the standard algorithm. We start with our first fraction, which is 5/6. We change division to multiplication, and we multiply by the reciprocal of the second fraction. In other words, we flip that second fraction over, so we multiply by 3/2. Now we have a multiplication problem to solve, so we go ahead and see if we can cross cancel, which we can. 3 divided by 3 is 1, and 6 divided by 3 is 2. We multiply straight across, and we end up with 5/4, and our final answer is 1 and 1/4 once we turn that improper fraction into a mixed number. Let's find the quotient of 1/4 divided by 2/3. We start with our original fraction of 1/4. We change the division sign to a multiplication sign, and we'll multiply by the reciprocal of the second fraction. When we flip that over, we end up with 3/2. I look to see if I can cross cancel, and I can't, so I multiply straight across. Our answer is 3/8. You may have noticed from our example that if we start with a fraction that is larger and divide by a smaller fraction, we end up with a mixed number as a result. However, if we start with a smaller fraction and divide by a larger fraction, we'll end up with a fraction for an answer. Let's try some word problems. At Mega Adventure Fun World, the average wait time for a roller coaster is 2/5 hour. If Einstwein's total roller coaster wait time was 4 hours in average length lines, how many roller coasters did he ride? When you're setting up a division problem, the order matters. It's not like multiplication, which is commutative. For example, if I have 10 divided by 2, I get a different answer than if I have 2 divided by 10. When setting up a division problem, you always want whatever it is that's being divided up to go first. Then you want to divide that by the number of people or parts or size or whatever it is. So we have to ask ourselves, is 2/5 hour being divided up into 4-hour units, or is 4 hours being divided up into 2/5 hour units? Well, we want to start with the 4 hours. His total was 4 hours, and each 2/5 hour represents one roller coaster that Einstein rode. Therefore, we'll want to have 4 divided by 2/5. Once we have the problem set up, we can easily solve. We start with our first fraction, and I'll put that over 1, and we'll multiply by the reciprocal of the second, which is 5/2. I then look to see if I can cross cancel, and both 4 and 2 can be divided by 2, and I multiply straight across and get 10/1. This tells us that Einstein rode a total of 10 roller coasters. Mega Adventure Fun World collects 7/8 tons of aluminum cans each day. Groundskeeper George can compact 1/24 ton of aluminum cans in each cycle. How many cycles are needed to compact 1 day's worth of aluminum cans? In order to set up our division problem, we have to figure out what we're starting with. In this case, we're starting with the whole or total amount of 7/8 tons of aluminum cans. We're going to break these down into 1/24 ton batches to figure out how many times Groundskeeper George will have to run the compactor. Therefore, when we set up the problem, it will be 7/8 divided by 1/24. Now we can go ahead and solve. We start with 7/8, and we'll multiply that times 24/1, the reciprocal of the second fraction. 8 goes into both 8 and 24, so I'll cross that off, and that will become a 1 and a 3. Then we multiply straight across and get 21/1. And we can see that groundskeeper George will have to run the compactor 21 times in order to compact 7/8 tons of aluminum cans. Well, Einswine, I'm very happy to learn that Mega Adventure Fun World recycles all those aluminum cans. Einswine? Einswine? What on earth are you doing? It looks like you've gotten turned upside down, haven't you? I told you not to go flippin' nuts when solving these flippin' division problems, or you start getting a bunch of wrong flippin' answers to all these flippin' problems. Okay? You only flip the second fraction and that's it, so we have to use that flip sparingly. Let's see if we can get you straightened out. Bye for now, math students.